Hi guys, welcome to DSD classes. In this video lecture, I am going to explain about XAD block in FPGA. So what is XAD means? It is Xilinx analog to digital converter block in FPGA. This is the Xilinx analog mixed signal module, referred to as XAD, is a hard macro. Okay, so it has JTAG and DPR interfaces for accessing the XAD's status and control register in 7 series FPGA. In previous lecture, I explained FPGA RTX 7 block diagram. So in that we have XAD block. So XAD block is Xilinx analog mixed signal. So we convert analog signal into digital signals. Here we have JTAG and DPR interfaces for control registers in 7 series FPGAs. So mainly analog to digital converters in FPGAs are has the following features. So dual 12-bit 1 MSPS analog to digital converters ADCs and up to 17 flexible and user configurable analog inputs. So here we have 17 flexible user configurable analog inputs and on-chip or external reference option. And one more feature is on-chip temperature and power supply sensors. We have a temperature and analog sensors. So using this we can we convert temperature and analog signal input into digital, and JTAGs access to ADC measurements. So these are some of the features. So so this is the block diagram of XAD block. See, here we have multiplexer. So multiplexer is a combinational circuit which will have 2 power n number of inputs and only one output. This output is given to second multiplexer. So these are all external analog signals. So and we have one temperature sensor and power supply sensors. So outputs of these sensors is given to multiplexer, and we have 12-bit 1 MSPS and 12-bit 1 MSPS. So these two, this is ADC channel A and this is ADC channel B. These are connected to on-chip reference voltages. So the reference voltage is 1 to 25 volts, 1.1 to 25 volts, and we have different so these are all memories. So we store this using read and write operations or read only. So this is RAM and this is ROM. So these two are connected to DRP. DRP is dynamic reprogrammable port. So read and write is bidirectional, whereas read only memory is unidirectional. So DRP's output we connect to JPT tag to the output out the world. So this is the block diagram of XAD of RTX 7 FPGA. So in this we have different, so FPGAs, in FPGAs RTX Xilinx we have different features. So one of the important feature is peripheral component interface, so PCI Express. So PCI Express is general purpose serial interconnect suitable for a broad range of applications across communications, data centers, enterprises, embedded, test and measurement, military and other market. It can be used as peripheral device interconnect, chip-to-chip interface, and as a bridge to many other protocol standards. So name itself indicates that peripheral component interface. So with the help of this, we can connect different input and output devices to the FPGA. So Xilinx provides high performance, low power integrated blocks for PCI Express as a hardened subsystem in many devices. So Xilinx also provide PCI Express, DMA and PCI bridge hard and soft IP blocks, so that utilize the integrated block for PCI Express boards with PCI Express connectors, connectivity kits, reference design, drivers and tools to make it easy to implement PCI based designs. Okay, so using PCI we can connect the peripherals. So next important feature is clock management. So as clock is high, the performance of the processor also very high. So there are many circumstances in which we need to generate new clock signals and efficient distributed them throughout a system. Modern FPGAs have dedicated clock management blocks, so that allows us to perform these two blocks. So we have different clock sources. Using these clock sources, we can generate the clock to FPGAs. A desired feature of an FPGA can be the ability to modify a given clock signal to generate new clock based on the requirement of the system. So we use a desired CMT. So what is CMT means? Clock management tile. So using clock management tile, we can generate different clock sources for different devices. So today's FPGAs incorporate powerful clock management block to facilitate the design process and reduce cost. We will refer to these embedded clock management block as CMBs. Okay, clock management blocks. Different vendors use different terms to refer their CMBs. For example, so Xilinx uses clock management tile or digital clock manager. Intel uses the well-known term phase lock loop, and micro semi use clock conditioning circuits. So CMBs in Xilinx, these CMBs are known as CMTs, clock management CMT, whereas in Intel they use PLL to produce the clock source. So, and we have in the 7 series FPGAs, we have different blocks to generate clock frequency. So the clock tails, the clock management tails provide clock frequency synthesis and jitter filtering functionalities. Non-clock resources such as local routing are not recommended when designing for clock functions. Global clock trees allow clocking for synchronization elements across the devices. So CMTs, each containing one mixed mode clock manager MMCM and one phase lock, and reside the CMT column next to the IO column. So beside CMT we have PLL and CMT IO columns. So this is about clock management. So we have different clock management. So next topic is high frequency serial IO transceivers. So in FPGAs, most of the devices use serial communication. Mainly we have two types of communications: parallel communication and serial communication. In FPGA we use serial IO transceivers. So input and output transceiver, which has transfer and receivers. So high speed data transport and devices integration are two main requirements for network development and installation. A network can vary from a system as small as the motherboard of a microprocessor and has large as the most complex telecommunication network. All such applications require reliable high-speed serial interconnections. So most of the devices like embedded systems or FPGAs, we use serial communications, because compared to parallel communication, serial communications are highly secured, and data required, a circuit also very simple. Here we use only one single cable to transfer the data, whereas in parallel communication devices we need to use more number of cables. So security wise also, serial communication devices are very secure devices. So we use serial IO transfer. The increased demand for more bandwidth to support inter-devices communication is driving the development of high-speed serial transceivers. A typical networking issues. So here mainly FPGAs nowadays operates with the clock frequency of 500 megahertz. So if the clock frequency is increases, the speed of the processors also increases. So this is about why we use serial IO transceivers in FPGAs. Thank you for watching.